Okay, this is lesson 11.1, Introduction to Sequences. So a sequence is a set of numbers with a particular order or pattern. Each number is a term, is called a term. Sequence with a limited number of terms is a finite sequence. For example, like if you had the sequence 1, 2, 3, 4, 5, and that was it, then that would be a finite sequence. There's a definite number. A sequence with an unlimited number would be something like, say, 0, 1, 2, 3, 4, 5, but then it has these three little dots at the end. That means it goes on forever. That's an infinite sequence. It has no ending. It actually goes to infinity. As far as the term notation, how we use it when we deal with these sequences, the first term is generally a sub 1 with a little lowercase a with a 1 as a subscript. Each subsequent term is denoted as a sub n plus 1. So it's the very next one, where n plus 1 is the term number in the sequence. So like if we had this example, 2, 5, 8, 11, 14, and so on, the first term, a sub 1, would be 2. The fifth term, let's see, 1, 2, 3, 4, 5, would be 14. But if they asked us to find the eighth term, we'd have to find some more terms to get there. So let's see, this is going up. Looks like they're adding 3 each time, right? So plus 3, plus 3, plus 3, plus 3. So that means our next term would be 17, then 20, then 23, then 26, 29, and so forth. I don't know how far we got to go. Okay, so the eighth term, 1, 2, 3, 4, 5, 6, 7, 8. So this would be 23, 9, 10, 11, 12. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, we need some more. The 13th term, the 14th term. And of course it does go on. Okay, so this is 41. Since each term value is paired with exactly one number, a sequence is a function with the following properties. So we have our domain, and the domain is the set of your term numbers. So the domain would be like first term, second term, third term, that kind of thing. The range is the actual term values. In an infinite set, the domain is the set of natural numbers. Now, there's two kind of formulas. There's recursive ones, and they have explicit ones, which we'll talk about on the next page. But recursive ones is a rule in which one or more previous terms are used to generate the next term. And the Fibonacci sequence is one of those. I don't know if you've heard of that before, but the Fibonacci sequence is 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, and so forth. And in the sequence, the first term is 0, the second term is 1. Then for each subsequent term, every term after that, is adding the two terms in front of it. So a sub n minus 1 plus a sub n minus 2. So notice that's what we did. So 0 plus 1 is 1. That's the third term. 1 plus 1 is 2, which is the fourth term. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. So it continues on by adding the two previous terms. So let's look at some examples of some recursive formulas. So number 1, first term is 25. So they want us to give the first 5 terms. So I know the first term is 25. It's kind of nice because they already give it to us. And then every term after that is taking the previous term and subtracting 7. That's what that is. So if I'm subtracting 7 from 25, I get 18. Subtract 7 again, I get 11. Subtract 7 again, I get 4. Subtract 7 again, I get negative 3. On this next one, it's a little bit more complicated. We have a negative that we're starting with. So first term is negative 2, because that's a sub 1. And now we have, let's see, 3 times the number in front of it plus 1. So 3 times negative 2 plus 1, that's negative 5. 3 times negative 5 plus 1 is negative 14. 3 times negative 14 plus 1 is negative 41. And 3 times negative 41 plus 1 is negative 122. Okay, so on the next page, you'll see number 3, we have the first term is 40. So we always put it first. And then let's see, each next term, we say half of that, and then add in the previous term. So half of 40 is 20, plus 40 is 60. And then we say half of 60, which is 30, plus the 60, that's 90. Half of 90 is 45, plus 90 would be 135. Half of 135 plus 135, oh, I think that's 202.5. Okay, so number 4. See, first term is 8, second term is 10. All right, so the next term, we take the previous term divided by the one that's 2 in front. So 1 in front divided by 2 in front. So it's going to be 10 over 8. Well, 10 over 8 goes to 5 over 4. And then we have 5 over 4 over 10. Oh, yuck. Okay, 5 over 4 over 10. 5/4 divided by 10. I think this gives you 1/8. And then you have 1/8 over 5/4, and I believe you get 1/10. And you can use a calculator for that if you need to. Now the next part gets a little bit harder because now they're giving us the values and they want us to figure out a rule for it, a recursive rule, and then find the 8th term. So let's see if we can figure it out. Some of these are tricky. 9 to 13 to 17 to 21 to 25. Oh, this one's not too bad because it looks like each time they're just adding 4. So that helps if it's like that. Then the nth term would be the term in front of it plus 4. And we have to specify that the first term is 9 when you write a recursive rule. Let's see, what is the next one? 1, 3, 8. Those aren't adding the same thing each time, so that's not going to work. Now this one is a trickier one, and sometimes you don't see it right away and it takes a while to figure out. Sometimes it just takes where you do enough of them till you start to see them. Oh wait, we didn't do the 8th term. I'll do it in a sec. Okay, so, because I'm not seeing a pattern here because it's plus 2 and then plus 5 and then plus, so it's not that, and we're not multiplying by the same thing each time that I can see. But since this is recursive, then that is giving me a hint. And turns out, let's write this. A sub 1 is 1. A sub 2 is 3. So notice what happens. If I take the 2 in front, so A sub n minus 1 plus A sub n minus 2, that's the 2 previous terms, and I multiply that by 2, it actually works because 1 plus 3 is 4 times 2 is 8. 3 plus 8 is 11. 11 times 2 is 22. 8 plus 22 is 30. 30 times 2 is 60. So that actually works. So that's a tricky one. That is a very tricky one. It's difficult to see, but that's what it is. Okay, so now let's find out the 8th term. So if I want the 8th term here, then, oh darn, I'm going to need the 7th term first, huh? And then add 4 to it. So that means I have to actually do it the long way. So 1, 2, 3, 4, 5, 6, 7, 8 to get to the 9th term. Okay, so Add 4, this would be 29. Add 4, 33, 37. 1, 2, 3, 4, 5, 6, 7, 8. Oh, that is the eighth term. Okay, so 37 is the eighth term. The next one, if we want the eighth term, then I'm going to need the 2 terms in front of it. So 1, 2, 3, 4, 5, 6, 7, 8. All right, so I'm adding these 2 together and times 2. So that's 82 times 2 is 164. 164 plus 60, oh gosh, I don't think I got enough space right here. Let me write this line bigger. This is 448. Add these 2 together and multiply by 2. Oh wow, it gets large quickly. So I have my eighth term is 1224, 1,224. Okay, so there we go. All right, now the explicit formulas. I like the explicit formulas much better. I think it's a little bit easier to understand. And basically it's very, very similar. So in the explicit one is when the nth term is defined as a function of n. So notice a sub n on this number 7 is 5 times n plus 1. So you always start with n as 1. So if I plug in a 1, 5 times 1 is 5 plus 1 is 6. So the first term is 6. The next term would be 5 times 2, which is 10 plus 1. 11. Third term would be 5 times 3 plus 1, that's 16, and so forth. So notice how I'm starting with 6, but I'm still each time just adding 5. So basically whatever I'm multiplying by the n by, that's what I'm adding each time. So there's the first 5 terms of that one. Let's see, this next one, this has an exponent. So if I plug in a 1 first, we always do the 1 first. 3 halves to the 1 minus 1 is 0. Anything to 0 power is 1, so that's 1. 3 halves would be the next one because that would be to the first power. 3 halves to the second power. Well, we're squaring the top of the fraction and squaring the bottom. So that's 9/4. And then cubed would be 27 over 8. And then the next one, 81 over 16. So you just kind of do all the tops separate than the bottoms because that exponent goes with both parts. Let's see, number 9, a sub n is n minus 1 over n plus 2. Okay, so this one's going to be a little bit more challenging. So this one we're going to plug in n of 1. So 1 minus 1, that's 0 on the top, so it's just 0. The next one, if I plug in 2, 2 minus 1 is 1. 2 plus 2 is 4, so that's 1/4. If I plug in 3, that gives me 2 over 5. If I plug in 4, that gives me 3 over 6, but that simplifies to 1/2. You always want to put simplest form if you can on these answers. And then if I plug in a 5, I get 4 over 7. All right, let's look at number 10. A sub n is square root of 3n. If n is 1, this would be just square root of 3. If n is 2, this is square root of 6. If n is 3, that'd be square root of 9, which is just 3. N is 4, that's square root of 12. But you know what? That can break down to 2 square root of 3. So I really should write it like that instead. And then square root of 15. You always should simplify it. All right, number 11 looks challenging. N cubed minus n minus 1 squared. So you may have to go off to the side, and you've got work right here, room to work, or you can choose your calculator if you like and plug it in. N of 1, this would be 1 minus 0, so that's just 1. Then we plug in 2, you get 7. You plug in 3, you get 23. Plug in 4, you get 55, and 5, you get 109. And you can check that with a calculator if you like. Now here's something I'm not sure that you guys seen yet. I don't know if you have or not. Have y'all seen this with the exclamation point? All that means is, oops, I'm clicking on something here I don't need to. Okay, this means it's a factorial. So like if you have n factorial, it is that number times every number down all the way to 1. So like if we had, say, 6 factorial, this would be 6 times 5 times 4 times 3 times 2 times 1. And you just multiply all the numbers together. There's a button on your calculator that has it. I'll have to show you, it depends on which calculator you're using. but there is one that can figure it out for you if you get to very large numbers. Luckily for us, we're not doing very large numbers. Let's see, what is that, the PRB button, I think? Yes. If you're using just the basic, that little blue calculator thing, then that is under that PRB button, which is right above the fraction one. And then you just tab over till you find that piece, if you need what that is. Okay, so if we plug in 1, this is 1 minus 4, so it's negative 3. If you plug in 2, that's 2 minus 4, which is negative 2. If we plug in 3, that would be 6, because you're saying 3 times 2 times 1. So 6 minus 4 is 2. If we plug in 4, what is 4? I'm going to actually use my calculator on this just to make sure I know how to do it. Except you really need to clean out your calculator first when you plug that in and clear out any old answers. Okay, so it's 24, so 24 minus 4 is 20. And then the next one would be 120 minus 4 is 116. Oops. I hit something wrong with my thing. I've got to be very careful here. There we go. Alrighty. Okay, so the next part asks us to write an explicit rule for each sequence and then find a sub 25, so the 25th term. All right, let's see. Explicit rules. Now, when I do these, I look for if they're adding the same thing each time, or if they're multiplying by the same thing, or dividing. Sometimes that's easier to pick out, but they don't always do that. Like on number 14, I notice here, look, they're just adding 2 each time, which is really nice, because to me, I figured out the pattern, and I don't even have to memorize a formula or anything. Let me show you. So whenever you have something, they're adding the same thing, and we'll get more into this in the next lesson, but if they're adding the same thing each time, then you put the number you start with. So we're starting with 9, and then we're adding 2, and it's always going to be n minus 1 times. Because notice, once you do the first term, the second term, you only added 2 once. The third term, you added 2 twice. So it's always 1 less than what you had before. And you can clean this up if you like, but you don't have to. You can just leave that as your answer. So first term, what you're adding or subtracting, n minus 1 times. It doesn't work that way if you're multiplying or if there's some other combination, but if you're adding the same thing each time, it's pretty straightforward. But notice on 13, they're not adding the same thing. But I'm hoping that you recognize that all of these answers are perfect squares, because that shows up a lot, like especially on the ACT and stuff and on tests. This is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So you always want to look for squares, and perfect cubes too. This would be a sub n equal to n squared. Okay, so now they want us to find the 25th one. So to find the 25th one, well, here I would just say 25 squared, and that's 625. On this one, the 25th one, well, we have 9, and then we had to add 2 24 times, and of course I'm just going to plug that in my calculator and see what we get, and I believe it is 57. So once you learn that, it's so much faster to get to than using that recursive formula. All right, last little bit. Write an explicit and recursive rule for each of these sequences. So here you just kind of got to figure them out, and some of these are very difficult. Some of them aren't as bad. Like on number 15, I'm seeing that we're adding 3 each time. So when it's something basic like this, it's really nice, because I know my explicit one, that's just straight out saying it, that's what that means. I'm starting with 4, and I'm adding 3 n minus 1 times. So it's pretty straightforward. The recursive one, you would say, well, let's see, the nth term is found by taking the number in front of it, which is a sub n minus 1, and adding 3 to it. But then you have to specify, well, the first term is 4, like that. Okay, as far as this next one, let's see, this looks like they're adding 1/2 each time. And a lot of times this is hard to see when you have fractions. So what you can do is rewrite all of these to have the same common denominator. And when you do that, sometimes it helps to see what it is. Because when they simplify them, it makes it more hard, more difficult to see. So notice on each one of these we're adding 1/2. So that means our explicit one means we're starting with 1/2, and then we're adding 1/2. Oh, keep hitting that button on the side. Sorry, y'all. Adding 1/2 n minus 1 times. Whereas the recursive one, we say you take the number in front of it, which is n minus 1, and then we add 1/2, and our first term is 1/2. There we go. Okay, so have some fun working on the problems.